ladies and gentlemen. Today we are working on squares and square roots. It is the 5th lesson of Chapter 4. A couple of vocabulary words to start off. First one, principal square root. Not the Mr. Nor, Mr. Washington square root, but the principal square root. The definition would be the non-negative square root of a number. So if we look at an example like letter A for number 1 here, and we have the square root of 16, we know, and I think you guys are familiar enough with square roots where I don't have to really go into what a square root is, but we know that the square root of 16 would be 4. And if it's the principal square root of 16, it is going to be a positive 4 because, again, the non-negative square root of a number is the principal square root. However, we know, if we're going to go in reverse, that 4 squared gives us 16, so therefore the square root of 16 is 4. However, we also know that the square root of 16 could be negative 4 because if we reversed it and did the square or the negative 4 squared, we would have negative 4 times negative 4, which would give us a positive 16. So in summary, we know that the square root of 16 could be a positive 4, or it could also be a negative 4. But if I'm asking you to identify the principal square root, I'm only looking for the non-negative square root of a number, which would be positive 4. You may have to go back and watch that one again, as there was a lot of information presented there. A perfect square is a number with integers. Sorry for the misspelling. That shouldn't be there. A number with integers as a square root. Examples of perfect squares would be 64, 49, 16, and 9. Just a quick example, the square root of 64 is 8 because 8 times 8 is 64. The square root of 49 is 7 because 7 times 7 is 49. And again, these are principal square roots. Technically 8 and negative 8, and technically 7 and negative 7 work. The square root of 16 would be 4 or negative 4 if I'm asking for all square roots of 16. Principal square root again would be 4, and so on and so forth. Moving down to example number 3, we have the negative square root of 49. The negative square root of 49 would be the square root of 49, which we know is 7, and we stick the negative in front of it. This example, the square root of negative 49, you cannot do a square root of a negative number, so therefore there is no answer. There is nothing that you can square to get to negative 49. You can't square 7 to get to negative 49, and you can't square negative 7 to get to negative 49. Therefore, any number, the square root of any number that is a negative, doesn't work. We'd say non-applicable, or we'd say nothing works. Number 4, we have 3 times the square root of 36. Problems like this, you would simply follow order of operations. Square roots actually act as parentheses, so we're going to consider them a parenthesis. So we'll do what is within the square root first. So therefore, we would do the square root of 36. In this case, we're just looking for principal squares. I will try to be clear, and if you're finding a principal square or just the square root, which would be both positive and negative. So in this case, the square root of 36 is 6. So our new problem would be 3 times 6, because the square root of 36 is what you do first. You get 6. 3 times 6 is 18. Moving down to number 5. We have the square root of 25 over 16. In this case, we're looking at an improper fraction. The numerator and the denominator both have to be taken into consideration when doing this. So we're going to find the square root of 25 and also the square root of 16 because both of them are within the parentheses or the square root. So in this case, the square root of 25 is 5, the square root of 16 is 4. Your answer is going to be 5/4, or you could also say negative 5/4 if you were not looking for the principal square, but for both squares. Number 6 takes it just a step further. We have the square root of 25/16 plus 3/4. So we'll do what's within the square root first because it acts as a parentheses. We got 5/4, and we are going to add 3/4 to that. 5/4 plus 3/4 is addable because we have common denominators. We add that together, we get 8/4, which is an improper fraction. We're going to convert that to the answer 2. So the square root of 25/16 plus 3/4 is 2. Number 7, another similar example to what we've been doing. We have the square root of 25 within a square root, therefore we're going to consider it a parentheses. We've got 2 times 5, because I do that first. plus 4. 2 times 5 is 10 plus 4. Order of operations, do multiplication before addition. 10 plus 4 is 14. Your final answer is 14. Number 8, just for fun, I don't know that you have any of these on an assignment, but we're looking for the cube root of 8. So we're not looking for the square root of 8, we're looking for the cube root of 8. Just a quick backtrack here. When we do the square root of anything, we don't put a number like I have right here because we're going to assume it is the square root of whatever number is within the square root sign. But if we want to find something a little bit different, like the cube root of 8, then we would have to put a 3 on the outside. Or if we want to find the fourth root of 8, we would put a 4th on the outside, and so on and so forth. And as you can see, I have an example down there with the fourth root of a number. In this case, we're going to find the cube root of 8, and that simply is what times what times what gives us 8. So we're going to look for something that, if you cube it, gives us 8. In this case, I think the example is easy enough for you to solve this, in the fact that you know that 2 times 2 times 2 is equal to 8. 2 to the third equals 8. So if we're asking for the cube root of 8, the answer is going to be the number 2, because 2 to the third power is 8. Number 9, similar problem. We're looking for the fourth root of 625. So again, just a little guess and check, a little mental math here. Or considering 625 may be a benchmark number for you, a number in which you know what times what times what times what gives you 625. I'm going to start off with just the number 10. Apparently it's not a benchmark number for me, because 10 times 10 times 10 times 10 is 100, 1,000. 10 times 10, oh sorry, 10 times 10 is 100. Let's see if I can get this to work here. I'm going to do 100 times the second 10 gives me 1,000. I'm going to do 100 times the next 10 gives me 10,000. So I know that 10 is too big of a number, because I'm only looking for a number that when you multiply it by itself 4 times, you get 625. So I do happen to know that 5 to the power of 4 is 625. So when calculating this, I'm going to say the cube root of 625 is the number 5. Last one, number 10. If you get a situation like this in which you have the square root of a non-perfect square, or this is going to be called not a perfect square, as you see in number 2 here, but this is a non-perfect square because you know in your heart of hearts that that 10 does not have a nice whole number answer as its square root. So in a problem like this, if you don't have a perfect square, you're going to express it as a decimal, rounded to the nearest hundredth unless told otherwise. So in this case, I'm going to take 10 on my calculator because I don't really want to calculate that out at the moment. I'm going to hit the square root button, and I get 3.16227766. I'm going to round that to 3.16, or 3 16 1/100ths, if I'm rounding correctly, which I did. Good luck!